Hey everyone, welcome. In this lesson, we will be applying our knowledge of congruence statements and triangle congruence criteria to formally prove triangles and, not a good color, triangles and parts of triangles congruent, right? So you've spent, I feel like it's been a lot of time talking about congruent statements, right? And these could be triangle congruent statements. These could be congruent statements that are talking about like corresponding angles or corresponding sides of triangles, right? So you've spent some time talking about that and how you appropriately mark and talk about, and maybe some reasons why, if you remember reflexive property and vertical angles and what happens if you bisect something, what perpendicular means, right? We've done some of this, and you did some in class today or yesterday, whenever you had class. To prove triangles congruent, we wrote some formal 2-column proofs. You also had an introduction to how to prove parts of triangles congruent, right? We talked about how, well, if these two triangles are congruent, then all of their corresponding parts must be congruent. So in this lesson, we're gonna practice some more with that and see some more examples. So I encourage you to either have this presentation printed out or pulled up, or you have your notebook out ready to join me and follow along. I also encourage you to pause the video and try some on your own. So let's start with a review. So here I'm given some information, right? So given MLN is congruent to PON. It's critical that we mark it off on the triangle. So MLN is congruent to PON, right? That's given to us. N is the midpoint of LO. N is the midpoint. Well, it's in the middle, so that means these two parts are going to be congruent. I also know that these are congruent. Why? They're vertical angles, right? They're formed by two intersecting lines. And my goal is to prove the triangle's congruent. Well, I'm staring at it. They are congruent. I have two angles. And let's see. It's the side that they share, right? It's the side that's both of them. So they're going to be congruent by angle, side, angle. Well, I just talked through the entire proof. So now we just got to write it out. So if you recall, we've got a 2-column proof, right? That's really been our focus. And we've got statements. We've got reasons. And for the most part, the order we do all of this stuff in matters. So I'm gonna start with the givens. I'm gonna start with angle MLN is congruent to angle PON. And my reason for that is given, right? Everything has a reason. If you can't explain why you're writing it, then you shouldn't be writing it. 2, N is the midpoint of LL. Reason? It's given, right? I knew this information. So what did this draw me to be able to say? I'm going to highlight one thing. What was I able to, when I just spoke about it? That's a terrible highlighter. That's good. When I just spoke about it above, before I wrote any of this stuff down, I marked these two parts congruent, right? If we said if N was the middle of LO, the middle, it's going to cut something in half. It's the middle. Like I'm standing directly in the middle. I'm halfway between the two parts. So that's going to mean that LN is congruent to ON. That is by the definition of midpoint. Right? That's the definition. N is a midpoint, so I could make this conclusion because that is what a midpoint is. Like that's the definition. I'm highlighting things, and maybe you know why I'm highlighting them. Maybe you don't, and that's okay. I'm going to address that in a moment. The next thing we knew was these two angles, right? Remember that I can't just say angle N, because N is the vertex of many different angles. LNM is congruent to angle ONP. And what were those? Vertical angles. Right? That's the definition of vertical angles. Like that is, by definition, all vertical angles are congruent. Now highlight that one too. So maybe, why am I highlighting these? Well, these are my 3 pieces of information that I need to make a conclusion, right? I'm then able to prove what I'm trying to prove. This should be, whatever you're trying to prove needs to be the last step. right? Like it can't go somewhere in the middle. I'm able to now say LNM is congruent to triangle ONP, and we already know the reason, right? I didn't do the proof until I knew it. Angle, side angle, congruence, right? So these were the three things. These were the two angles and the side between them that I used to get to step 5. I need 3. If I forgot to write something down here, I'd be missing a step, and that's why I tend to like to highlight it. There are a few things that could be moved around in here, but not too many, right? Like I need number 2 to go before number 3. I can't move these. They have to go in this order. If I wanted to say number 4 earlier, I could do that, right? Vertical angles don't depend on anything else. But this triangle congruence statement at the end, when I'm trying to prove, needs to go on the last step. The other piece of it I really wanted to talk about was stuff like angle, side, side angle, side. That stuff, those are reasons to prove triangles congruent. So if I'm not writing a statement about 2 triangles being congruent, I shouldn't be using one of my 5 triangle congruence criteria. So that's a brief review. So what I would love for you to do right now is pause the video and try this on your own. This is a fill in the blank proof, right? So I'm giving some information, think about what I'm trying to prove, and then how do you fill in the pieces here? So hopefully you've had an opportunity to try it, maybe. JL, ooh, what does that stand for? Ray, it's Ray JL. Bisects, think about what that means. Angle KJM, and JM is congruent to JK. So JL bisects angle KJM. Given. Okay. JL is congruent to JL. That's not given to us, right? That's not given up here. Let's look. Oh, we've seen stuff like this before. Something's congruent to itself. What's it called? Reflexive property. Okay. Definition of angle bisector. Did it say angle bisector somewhere? Whoop. Oh, JL. Right here. It bisects. Ooh, that's not nice. This angle right here. Well, if you bisect an angle, it is cutting an angle in half. If I cut an angle in half, I get 2 parts of that angle. 2 congruent parts, right? Like I get 2 halves of the angle. So I'm going to end up with this angle and this angle being congruent. Well, how do you name them? Angle KJL is congruent to angle MJL by definition of angle bisector. Okay. So here, I'm gonna highlight the things again. So that's important. That's important. It's all important, but those are important. Okay, so number 4. Oh, it's another given. Have I not said about my givens? Oh my goodness, I haven't. JM is congruent to JK. So then how are the triangles congruent? Well, I've got 5 different reasons. So which of the 5? Think about that. So let's look. I've got side and side, and I've got an angle, right? Even if you look at it this way, where's my highlighter? I lost it. I wrote down 2 sides and an angle. So I either have side angle side or side side angle. Well, side side angle is not a reason unless it's a right triangle. So even if you're unsure, look how that, I eliminated it. And I was like, well, I have 2 sides and an angle. I'm down to 2 different options. I can't say not congruent. That's not an option. If they're telling me to prove it, it's possible. I just have to go step by step. So here I've got 2 sides, and it is the angle between them. So it is side angle side congruence. How fun. Let's do another. So for this one, I think this is a really good place. Pause the video. Do this. You guys got this, right? Look at it, write it out for yourself and see where you get stuck. See what you're able to fill in. So, whoa, that's weird. I have it in the wrong order. Sorry. Given this, we're trying to prove these two triangles congruent. Okay, so I want you to pause it. I'm going to, in a moment, write in a few different things. So if you're struggling, unpause, often called play, and I'm going to fill in a few before I just like dive in and do the entire thing. So here's what I'm going to write down. I'm going to say given here. Here I'm going to say I'm going to go with that. So maybe if you were having some trouble, and you want to see, maybe this helps push you in the right direction. Okay, let's see. So let's fill these in. So I'm going to start with my given first. Well, there's only one given. So let's do that. DC and BE bisect each other. That's a loaded statement, right? So DC bisects BE. So it's DC is going to cut BE in half, and BE is going to cut DC in half. So it's like two things are being said here. So why are we able to say CA and DA are congruent? Did you write down definition of bisect? What about this one? Why are we able to say that BA and EA are congruent? Maybe that's also because of definition of bisect. They bisect each other. Here, number 4 is telling, oh, bless me. Number 4 is telling me something about vertical angles. So I should probably look for vertical angles, shouldn't I? Oh, right here and here. Okay, so let's name them. Angle CAB, angle CAB is congruent to angle DAE. As if you say BAC and EAD, you're completely fine as well. And that's because of vertical angles. All vertical angles are congruent. Okay, and then this last step, let's see, what do I have? I have 1, I have 2, oh, check that out, 3, that's why there's only one more step. I've got 2 sides, and I've got an angle. 2 sides and an angle. The angle is in between, so it's side, angle, side. So I'm able to then end this and say ACD is congruent to ADE. Literally just pull it out from here. What are we trying to prove? And that's by side, angle, side congruence. So just make a note of like, were you able to do that completely on your own? Where did you maybe have some struggles with it? When I then gave it to you as a fill in the blank, did that push you in the right direction? You understand it when I do it with you. So think about those things and what you may need to work on. Okay, so let's look at this, because this is what we talked about in class. So once we know, like right here, once I know that these two triangles are congruent, I can add something else in here. I can now say that something like angle D is congruent to angle C. Look at where they are. Angle C. Oh, this isn't ACD. What am I doing? ACB. And A, oh my goodness. So sorry. Right, so I can say angle D and angle C are congruent. Why? Because corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. CPCTC, which we spoke about in class. Right, so once we have proven two figures congruent, all of their corresponding parts will also be congruent. That's why when we've been giving you stuff like triangle FMJ is congruent to triangle LPQ, and then we can say statements like, well, if this is true, what is FJ congruent to? Oh, LQ, right? We can just look at like corresponding parts are congruent. That is what's true, right? So we can say that corresponding parts of congruent triangles are congruent. CPCTC. Right? So order of these letters matters. You can't switch them up. So if you need to work through this by writing something like this out, go for it. Corresponding parts of congruent triangles are congruent. Just keep saying it. Go tell your friends. Let's do an example. So let's see. Given BD is, what does this mean? Perpendicular. I don't see the word bisect anywhere. So just perpendicular, right? That means 90 degrees. BD and AC are perpendicular. I'll go ahead and add that 90-degree symbol in. Both of these would be 90 degrees. It'd be congruent. D is the midpoint. D is the midpoint of AC, so I know this and this are congruent. Our goal is to prove these two angles congruent. We don't know it. That's going to be my very, very, very last step. And before I even do that, I somehow got to prove these triangles congruent. So watch what I'm going to do. Remember, every statement has to have a reason. Okay, so I'm going to start with this. BD is perpendicular to AC. Given. I'll say angle BDA and angle BDC are right angles. Right? I marked that off because that's the definition of perpendicular. I'm going to write the symbol. Okay. So if they're both right angles, they've got to be congruent. So let's say that next. BDA is congruent to BDC. The reason for that one is literally what we just said. All right angles are congruent. I shall highlight it. There's one statement. Okay. Let's go with the other given now. What was my other given? D is the midpoint of AC. Given. What did we know from that? What could we conclude? If D is the midpoint, it's the middle, it's halfway between A and C, we were able to mark off AC, oh no. AD is congruent to CD because we know what a midpoint is. Definition of midpoint. Here's another thing. So I've got two things. Is there a third that we haven't even spoken about yet? Anyone thinking about this? The side that they share, right? Can't I say BD is congruent to BD? What's that called? Reflexive. So my triangles have to be, they have to be congruent if I'm proving that part of the triangle is congruent. So let's go with this. I've now got three things. I have two sides and an angle. Two sides and an angle. Is the angle between them? Two sides. And yeah, it's the angle where they meet. So side, angle, side. So triangle. And notice like, even though I'm proving a part of a triangle congruent, I haven't done much different. BDA is congruent to triangle BDC by side, angle, side. Okay. Now my triangles are congruent. All their corresponding parts must be congruent. I now know this, so I can go a step further and say, well, angle, what was I trying to prove? A must be congruent to angle C by CPCTC, because corresponding parts of congruent triangles are congruent. This CPCTC comes after triangles have been proven congruent, right? Because it's saying corresponding parts of congruent triangles. If we don't know that the triangles are congruent, we can't use it, right? So this was a bit of a longer proof. So hopefully this makes sense of how this kind of all ties in together. This one was a bit tricky, but think about, like, were you able to follow along? Where are you maybe confused? Maybe write some of those confusions down so you can be like, I need to ask my teacher this. All great things to do. So this is the one that we are going to finish up with. And what I would love for you to do right now is try this one on your own, especially if you haven't tried any of them on your own right now. So I'm going to give you all I don't know if hint is the right word, but a push in the right direction if you need it. So I'm going to tell you how many steps I would use. Six. I would use 6 steps. I think that's the shortest amount of steps you can do this in, unless you decide to combine 2 things, which is, I guess, reasonable. Hopefully you've tried it. If you haven't, you're like, oh no, she started talking again. Pause the video. That's how I stopped talking. Angle E is congruent to angle P because it's given. Angle E is congruent to angle P. K is the midpoint of EP because it's given. What does that mean? That doesn't give us anything to, like, highlight, right? We only highlight the congruent statements. So K is the midpoint of EP. Well, sorry, not drawn to scale, my friends. This and this are congruent, right? K is halfway, it's the midpoint. So EK must be congruent to PK. By definition of midpoint. I should highlight that, right? There's my second congruent statement. Okay, I'm not given anything else. You know what, actually? I'm going to go ahead and end with this. I'll stick that down there because I know it's going to go there. Okay, so do I know anything else, though? What are my look-fors? Maybe these 2? And I should not just call them K, right? E, whoa, Miss Gowan. EKG is congruent to angle PKM. What are those called? Vertical angles. So there, I've got 3 things. I wrote 2 angles and a side. So is the side between them or outside? Let's look. 2 angles. So angle, angle. Oh, the side that I know is the one that's, like, it's shared. It's between them. It's not on just one of them. I highlighted it twice. So that's between. So then I'm able to conclude that the triangles are congruent, right? I can say EKG triangle, notice the different symbol there, is congruent to triangle PKM. My reason, well, it's one of my 5 reasons, and we just wrote it down, is angle side angle congruence. Therefore, if these 2 triangles are congruent, which they are, we've proven them congruent, I can say any corresponding part of the triangle must be congruent to its corresponding part on the other triangle. So EG and PM must be congruent by CPCTC. Corresponding parts of congruent triangles, because I already proved them congruent, are congruent. Amazing. So what we did in this lesson, you guys did some of this throughout class and in the last video lesson and this past class period, was we applied our knowledge of congruent statements and triangle congruence criteria to formally prove in these two-column proofs triangles congruent as well as parts of triangles congruent with CPCTC. So just recognize that in order to use CPCTC, we must first say that triangles are congruent. When we are saying that triangles are congruent, we need to use one of our 5 reasons, which are side, 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 angle, side, angle, side, angle, 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 side, and HL. Okay, so I really want to encourage you guys to make sure that you've watched this video and you're clear on the objectives and the objectives that we covered over the last day or so. You guys have an assignment that you're completing for us this weekend that is some points. So make sure that you get that done. And then when we see you next, you will have your final quiz for the quarter. And we will be doing that together when we see you in class on this topic, on triangle congruence proofs. So I will see you all next time. Thanks, everyone.